Oh, what's up, everybody? Day 16 of the advent of cyber. Let's go ahead and jump into it. All right. Today, day 16, we are doing some more secure coding with SQL, the king, the carolers sing. I have not looked at this yet, so I have no idea what we're doing here. So let's go ahead and read through and find out what our tasks are for today. All right, set to have all of their apps secure, the elves turned towards the one Santa uses to manage the present deliveries for Christmas. Elf McSkidy asked Elf Exploit and Elf Admin to assist you in clearing the application from SQL injections. Ooh, interesting. When presented with the app's code, both elves looked a bit shocked, and none of them knew how to make any sense of it, let alone how to fix it. We used to have an Elf McCode, but he founded a startup and helps us no more. After a bit of talk, it was decided the elves returned carrying a pointy hat and appointed you as the new Elf McCode. Oh, fantastic. I'm not a coder. So I guess congratulations on my promotion. Well, I'm not sure we're going to secure this app if I'm the coder. But let's see if we can figure it out. All right. We already know how to deploy a virtual machine. That's already done. You can see that up here. So let's have an SQL refresher, or maybe an SQL learning tool. All right, SQL, aka Structured Query Language, is the traditional language used to ask databases for information. When you build any application that relies on a database, the app will need to create SQL sentences on the fly and send them to the database engine to retrieve the required information for your app to work. Luckily for us, SQL was built with the simplicity in mind, and its syntax is supposed to resemble straightforward English sentences to make it easier for programmers to understand. Well, that sounds promising. But before explaining the SQL syntax, let's talk a little bit about the specific database engine used in our app. MySQL. MySQL stores information in structures called tables. Think of them as any table in a spreadsheet or in a spreadsheet document where you have columns and you have rows. For clarity, let's check out one of the tables in use in the current application where the toys are stored. All right. So, looks just like any other spreadsheet. Probably everybody has used Google Sheets or Microsoft Excel. We've got a row and we've got a column. So there's our column ID, our creator ID, the name. I'm assuming that's the name of the toy, a description of the toy, fabrication date or the date created, how many they have in store or in stock, and a minimum score. Don't know what the minimum score is. And then we've got on each line. All right, perfect. As you can see, each row of the table corresponds to a different toy, and each column is a field of data that describes the toy. Looking at the third row, we can see that our toys table contains a toy named car, and that there are 12 units available for it. That's pretty easy. So third row, car. It's a wooden car with rolling wheels, and there are 12 units in stock. All right. As mentioned before, when an app needs to retrieve information from a database, it will need to build an SQL query. Queries are simple instructions that ask for specific data in a structured way that the database can understand. To query this information, we will use a select statement, indicating which rows and which table we want to retrieve. If we wanted to get all of the columns from the toys in our table, or from toys in the database table, we could use the following statement: select asterisk for all from toys, which I'm assuming toys is the database. Notice the asterisk which indicates that you want to retrieve all columns from the table. If you need to ask for a specific column, you can replace the asterisk with a column-separated list of columns, or a comma-separated list of columns. For example, to retrieve only the name of the quantity columns, you can issue the following SQL query. Select name and quantity from toys. Oh, pretty simple. Okay. All table rows are returned in both cases before, but you can filter those if needed using a where clause. Suppose you want to filter the results of the query so that you only get the toys for which there are at least a quantity of 20. You could do something like the following. Let's scroll up. So we could do select, comma, quantity from toys, so get the columns of name and quantity from table toys where the quantity is greater than or equal to 20. All right, makes sense. In real-world apps, you are likely to find much more complex queries in some cases, but what we've covered so far should be enough for the rest of this room. Whew. All right. Don't want to get overloaded. Oh, great. Now I'm seeing PHP. Fantastic. Like I said, not a coder. All right. Sending SQL queries from PHP. Well, this should be fun. Now that we understand how a select statement works, let's see how a PHP application builds and sends a query to MySQL. Although we are focusing on PHP and MySQL, the same idea generally applies to all other programming languages. All right, good to know. The first step is always to get a connection to the database from our code. So to do so, PHP includes the MySQLi extension. So it includes MySQLi extension, which provides the MySQLi _connect function. The function receives the IP or the name of the database server as the first parameter. So server followed by the username with user and the password with pwd. All right. And finally, the name of the schema to use in schema, which is just the identifier of the database to which we are going to connect. As a result, the function returns a connection handler, which can be used to send further queries. Think of the connection handler as a variable that holds the connection information to the database so that the queries can be sent to it. All right, this kind of makes sense. So we've got server equals database, and this is kind of like a variable. So we got server equals database, user equals logistics user, the password equals somepass123, very secure password. Schema is going to be logistics, which logistics would be the table, if I'm correct. So we're going to say the database equals MySQL connects to, and then within this little string, it's going to pull all these variables in there. Once a connection is made, we can use SQL queries using the MySQLi _query function. The first parameter we pass to the function is the connection handler. Is the connection handler we got before, and then the second parameter is the string of our SQL query. Ooh, man, this is going to be brutal for me, guys. As a result of executing the query, we obtain an SQL result set, and we store it in the elves _rs, which I guess they're saying that's going to be result set variable in our example. A result set is nothing more than an object that contains the results of our query, which can be used in the rest of our program to access the resulting data. I guess, okay, so that's going to be kind of like a placeholder. As you can see, it is all as easy as building a string with our query and sending it to the database. Yeah, sure. All right. Now, here's where things get interesting. If you check Santa's website, or the web application, you can access the elves profile by using a URL like this. Okay, so let's check out this website. bring that bad boy over here. Come on. All right. So we got our website. We even have elf rankings on here. Okay, so we've got our website up. Now, depending on the number you put on the ID parameter of the URL, you get served the profile of a different elf. Behind the curtains, this works by creating an SQL query that embeds the ID parameter value and then returns the information from the corresponding elf. So this is kind of like what we did last night. Remember where we kind of went in and changed our variable up here. So if we put like 5, do we get another elf? Now we get Elf McCode, right? What was it? Was it 0 last? Oh, hold on. Come on, back me up. There we go. Last night, 0 was where we actually got our flag. Yeah, full stack, bro. So there we go. So yeah, putting in a different ID, this is actually throwing out the query in the background. Got it. So in the code, it would look like this. Query equals select all from users where ID, and then we're going to get the ID from up here. Elves underscore rs equals MySQLi underscore query, and then the object is db comma query. Okay. Let's scroll up some. The first line builds the SQL query by concatenating the get ID variable as part of where the clause is. Note that in PHP, you can access any parameter in the URL as get and then name of parameter. This query will ask the database for any column of the table users that correspond to elf with the specific ID. The second line sends the query and returns the information of one particular elf. As the result, set in the store where elves are as variable. That did not sound right. All right. The rest of the website then parses the result set and renders the page accordingly. If you test the website, you can see that it works as expected. You, however, introduced an SQL injection vulnerability in your code that could allow any attacker to dump your whole database. Not me, I didn't do that. So SQL injection, not a good thing. So if you're going to build something and you have SQL injection, you're... The problem with the method shown before is that it takes untrusted input from the user and concatenates it to the SQL query without any questions asked. As seen in the previous day's task, our app should thoroughly validate any input the user sends before using it. If it doesn't, unexpected things will happen. In the case of SQL and our example, the attacker can send an SQL syntax through one of the various parameters of the app's URL, which might end up being concatenated to some SQL query in code, potentially changing its intended purpose. All right, let's get back to the elf's profile page to understand this better. Remember, the application is creating a query by concatenating whatever is sent to it in the ID parameter as part of the where clause. So we got our query select. We're selecting everything from the user's database where the ID is equal to whatever ID we put in up here. So if the attacker sends the following through the ID parameter, so basically this is saying, let's copy it. This parameter, if I read this correctly, this parameter says if the ID is -1 or if the ID is 4. Okay? So when PHP concatenates -1 or ID equals 4 to our SQL statement, it will end up with this query. Select all users where ID equals -1 or the ID equals 4. Suddenly, the attacker has injected an SQL statement or an SQL syntax that, when concatenated to our original query, ends up serving up data of the elf with ID 4 for some weird reason. All right, so what happens if we hit enter? So we get number 4. Okay, so if we remove this, let's do this. Let's see if what they're saying is right. So we should get the same if we type in just 4. So ID 4 is definitely right. Okay. Interesting. So if we put in -1 or ID equals -4, or ID equals 4, we get the same thing as 4. Man, tell you what, reading this, I feel like...
You're so dumb. You are really dumb. For real.
That's how I feel right now. Talk about being Greek to you. All right. Continuing on. If we read the resulting query string, we can see that our where clause was modified to filter only the elves that either have -1 or ID 4. Since the ID values used by the database are likely all positive numbers, no elf will ever match -1. Therefore, the database will only return the elf that's equal to 4. Okay, got that. While this example shows a harmless injection, a skilled attacker can try and get your server to run much more complex SQL queries and potentially force the database to return any data on the table they want. Just as an example, look at what happens when you put in the following parameters. Okay, so we're going to say, if I'm reading this correctly, I can at least read this stuff, I just don't know what the hell it does. So if I read this correctly, we're going to it. We've got our ID of -1, which does not exist, right? And we're going to create a union between the select all of null, username, password. I have a feeling what's about to happen is we're about to get a dump of all of the users and passwords. Yep. So we're going to -1, and then we want to pull it in, and we want to select null, user password, null, from the users table. So I bet you if we hit this, we're about to get a big fat dump of all the users and their passwords. Ah, there we go. So Santa's password is ho 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 2022. Elf McSkidy is Skitty Pass Python. So yeah, okay. I'm getting it. All right. The SQL injection will make the database return all of the user passwords. We see that. Santa won't like this for sure. If you are interested in learning more about SQL injection from an attacker's perspective, you can check out our SQL room. Okay, that may be something we look at later on down the line. For the rest of this task, however, we will focus on how to defend this side and look at ways to prevent SQL injection in our code. So don't worry too much if the above URL looks hard to understand. All right, good. So we're moving away from the red side, and we're going to go to the blue side, and we're going to see if we can't defend this. Let's scroll up. All right, how do we fix this app? Fixing the app with Elf Exploit and Elf Admin, and us, Elf McCode. Armed with all this knowledge, we are ready to fix this app. You'll have access to a simple editor and can modify the app's source code during the task. Any changes you make in the editor will go live instantly as long as you have saved your changes by pressing Ctrl+S. All right. If you are using the VPN connection, you can access the code editor from any browser of your preference. If you are using the attack box instead, Firefox is installed, blah, blah, blah. Yeah, we are using the VPN because I like jumping on my own machine, so we're going to, you know what I really need to do? We don't need to copy and paste that. Let's just click here, delete, and let's go to the page. All right. All right, so to enter the code editor, We are going to put our secure name in as Coder and our secure password as Coder because we are all about security. And I lost my mouse when I clicked on it. Give me a mouse back. All right, there we go. Oh, and remember me. Remember me, Coder. All right, let's click login. No, don't save it. Okay, we've got our file manager. Let's scroll up. We got past our Coder. In addition to the code editor, you will have access to a chat communication with Elf Exploit and Elf Admin. While they don't speak too much, you can request them to check the application for you. If you remember correctly, they don't know a thing about coding, and neither do I. They picked the wrong guy to code it. However, Elf Exploit will help you identify parts of the app that are vulnerable by SQLi injection or SQL injection. Elf Admin, on the other hand, will check that the application is running as expected. So if you make a change that breaks the application somehow, he will let you know so you can roll back and try again. In combination, they will tell you if your changes solve the vulnerability while avoiding altering the app as it's supposed to work. Oh, put me in charge of this. I'm going to blow it up. To ask the elves, all you need to do is click on recheck the app. So there we go. All right. So remember, you can always check the website after any changes by visiting the following link. Okay, well, let's go ahead and let's copy that and let's put this in another tab. Because we're smart coders like that. Okay. Now let's get to work. Let's do that. Let's get to work. We've learned a lot about SQL injection so far. And I still feel like a... One of the easiest and most effective ways to prevent SQL injection is to ensure that the data that the user can manipulate that you are concatenating as part of the SQL statement is actually from the type you expect. Let's go to our elf chat and click on Run Checks button. All right, but nothing's gonna work. All right, take a look at the following URL. By injecting the SQL element, I was able to manipulate the database to return a specific elf record. All right. Can we copy the link? Okay. Elf Exploit should tell you that he successfully injected a SQL via the ID parameter of elf.php. Yep, elf.php. Let's open that file in our code editor and look at lines 4 and 5. So elf.php, there we go. Lines 4 and 5, queries. Okay. Query equals select all from users where ID is, that's what we talked about earlier. And then elves underscore rs equals MySQLi underscore query. So the website takes the ID parameter from the URL and concatenates it into a SQL query as shown. We can reasonably assume that the website expects an integer to be set. To avoid injections, we can convert whatever the user inputs into the ID parameter to an integer. For this purpose, we will be using the int val, which I'm assuming stands for integer value. This function will take a string and try to convert it into an integer. If no valid integer is found on the string, it will return a 0, which is also an integer. To clarify this, let's look at some of the values and how they will be converted. So int val 123 would be 123, int val TryHackme would equal 0, int val 123 TryHackme would be 123. So it's only taking integers and numbers in there. No longer can you put a big old long line of string. Putting this to use, we can modify line 4 to make it look like this. let's go ahead and just copy. Actually, no, let's not copy. Let's be coders and let's code. So we've got query select from users where ID equals, and then we're going to put int val in front of that. So dot int val, and then we're going to close these inside here. Close that all. Yeah, we're going to close the whole thing up inside. Oop. Close it all up. Perfect. That way, even if the attacker sends a SQL injection payload via the ID parameter, the app will try converting to an integer before concatenating it as part of the SQL statement. In the worst case scenario, the string gets converted to 0, which is still harmless in this particular case. All right. So make sure to press Control S. Alrighty then, Control S. Oh, there it goes. I see at the bottom, file saved. Control S, save your changes, and ask the elves to recheck. This time, Elf exploit will again tell you he can inject SQL, but in a different way. All right, let's see what happens. Oh, he's telling me the website's working fine. Okay, good. Look at the following URL. So we're looking at elf.php ID 9999 union select blah, blah. By injecting some SQL, I was able to make the database return the number 313333 as the first toy name. Okay. So we saved it. Okay. This happens because the ID parameter is used 2 times in Elf PHP. The form separates 2 SQL queries, one to get the elf's information, the other to get any toys built by them. Find where this happens and fix the vulnerability. Once you do, ask the elves to recheck, and if your fix is correct, you'll get the first flag. Oh, fantastic. Notice that for most data types, you will be able to make something familiar. If you expect to receive a float number, you can put float val. Just the same, even if the values are not numeric but follow the same specific structure, you can implement your own validators to ensure that the data conforms with a given format. Think for this example of a parameter used to send IP addresses. You could quickly implement a simple function to connect if the IP is well formed and opt not to run the SQL query if it isn't. Alrighty then. Let's see. It looks like we still got this. We're gonna do the same thing here. Right? We need to put dot int val and tval. I saw this one right off the bat. We're gonna throw the parentheses around here. And let's hit run. Website's running all right. So what did we miss? What did we miss? Get the ID. Take a look at the following. Elf PHP. By injecting some SQL, I was able to make the database return the number as the first toy name. Select bank from the toys. I'm pretty sure that it's not going to have anything to do with this part, because this is all right. Let's go back and read this. Notice that for most types, you'll be able. Let's reread and make sure we read this correctly. I told you guys I'm going to get stuck on this one. This happens because the ID parameter is used twice in Elf PHP. So we've got ID and ID right there. To form two separate SQL queries, one to get the elves information and another to get the toys built by them. Find where this happens and fix the vulnerability. Once you do, ask the elves to recheck, and if your fix is correct, you'll get the flag. Oh, you know what? We did that, but you know what we didn't do? We didn't hit save. Now the file's saved. Let's check it again. Boom! Yeah, we did it right. We did it right. We just didn't save it. Let's copy and paste and get our first flag. Now I feel like a winner. Scroll down. Scroll. Yes. Yes, sir. All right. Now let's go back up. All right. We talked about float values. Don't think we're going to work on that. Let's see. All right. Fixing the SQL injection using prepared statements. While in some cases you may have secured your code with a simple validator, there are situations where you need to allow the users to pass arbitrary strings through a parameter. One example of this can be seen in the search bar of our application. Every time a search is done, it gets sent a search toys PHP, or it gets sent to search toys PHP via the queue parameter. Let's see. If you ask the elves to recheck the application right now, Elf exploit should have a way to take advantage of the vulnerability in the parameter. If we open search toys.php in our code, we can quickly see that the query is built in lines 4 and 5. All right, let's see. I can inject SQL into the application. So search toys PHP. So here's our search toys PHP. Let's close Elf. All right, lines 4 and 5. We need to pull this over so we can see. All right, so lines 4 and 5. Let's scroll up. Okay, query equals select all the toys where name, like, and then get q parenthesis or not parenthesis percent sign or description like. Okay, toys. So then that's built. So here the q parameter gets concatenated twice into the same SQL statement. Notice that in both cases the data in q is wrapped around single quotes, which is how you present a string in SQL or SQL. The problem with having PHP build the query is that the database has no other option but to trust what is given. If an attacker somehow injects SQL, PHP will blindly concatenate the injected payload into the query string and the database will execute it. Hey, and just like we learned yesterday, what we say, we don't trust the user. You don't trust them to put the right stuff in. So we have to build this app with no trust. Or zero trust, right? All right, while there are a couple of ways to go about this, the safest bet is to use prepared statements to prevent SQL injections. All right, so what the hell is a prepared statement? Prepared statements allow you to separate the syntax of your SQL sentence from the actual parameters used on your where clause or on your Santa Claus, on your where clause. Instead of building a single string by concatenation, you will first describe the structure of the SQL query and use placeholders to indicate the position of your SQL parameters. You will then bind the parameters to the prepared statement in a separate function call. Okay, so it looks like we've got select all from the toys where name like question mark. We've got character or description like question mark character. Instead of providing a single SQL query string, we will send any dynamic parameter separately from the query itself, allowing the database to stick the pieces together securely without depending on PHP or the programmer. Let's see how this looks in the code. Let's scroll up. We're at the top. Whoa, not that far. First, we will modify our initial query by replacing any parameter with a placeholder indicated with the question mark. Okay. This will tell the database we want to run a query that takes 2 parameters as an input. The query will then be passed to the MySQLi and _prepare function instead of our usual MySQLi query. MySQLi prepare will not run the query yet, but it will indicate to the database to prepare the query with the given syntax. This function will return a prepared statement. Okay, so we look on here, we got query equals select everything from toys where like equals question or description like question. Oh no, where name is like question or where description is like question. Okay. Then we're going to create statement, and our statement is going to be MySQLi _prepare. So we're going to prepare that database query. To execute our query, MySQL needs to know the value to put on each placeholder we defined before. We can use the MySQLi statement _bind _param function attached variables to each placeholder. This function requires you to send the following function parameters. Oh, there's so much to this. There's so much. The first parameter should be a reference to the prepared statement to which to bind the variables. The second parameter is a string composed of 1 letter per placeholder to bind where letters indicate each variable's type. Since we want to pass 2 strings, we will put SS in the second parameter, where each S represents a string type variable. You can also use the letters I for integers or D for floats. Why would you use D for floats? Why not use F? You're going to use I for integer and S for string. I thought this was supposed to be readable. Anyway, you can check the full list of PHP's documentation. After that, you will need to pass the variables themselves. You must add as many variables as placeholders defined within the question mark in your query, which in our case are 2. Notice that in our example, both parameters have the same content, but in other cases, it may not be so. The resulting code for this would be as follows. All right, so where's our Q equals, here, let's scroll it up. The resulting code should be Q equals %, get Q %, MySQLi _statement _bind _ and param statement SS Q. Once we've created the statement and bound the required parameters, we will execute and prepare statement using MySQL statement execute, which receives the statement statement and only its parameters. MySQL statement execute statement. Holy smokes. All right. Finally, when the statement has been executed, we can retrieve the corresponding result set using the MySQLi _statement _get _result in parentheses. Passing the statement as the only parameter will assign the result set to the toys variable as the original code toys, and then get the result of the statement. our final resulting code should look like this. Holy Jesus. Okay. I am going, I believe, I don't know what we use. Hold on a second. Let's do this. I don't know what we use to comment stuff out in PHP. Let's check this out real quick. Okay. That'll work. That's what I was going to do, but I wanted to make sure before we did. Okay, so let's comment this. We're going to comment there. And we're going to comment here. And we're going to take all of this. Our final resulting code should look like this. So we should be able to copy all of this code. Now we're going to, come on, copy. And we're going to put this on this line. We're going to paste it in. Hopefully we don't blow this all up. Hopefully this works. Control S. We're going to save the page. Control S. Save the page. Come on. Oh, there it goes. File saved. File changed on server. Would you like to load the updated file? Reload the file. Okay. Be sure to save your changes if you... Okay, so now if we check this. So what I did here, for those that don't know, all I did was comment this out. So this query was, or these statements are already in here, and that's what we used before. What I did is I went ahead and commented it out. In fact, what we can do is we can put another comment in here, and let's say old way to query. Just for now. And that code isn't actually going to run. It's just basically there. It's in there for a reference for later. If this down here doesn't work and it breaks everything, we can always remove this, uncomment that, and our page is back up. But let's see. Hopefully, by putting this in, we can hit run checks and we should be good. Did we break it? No vulnerabilities. Yes! Okay. So, we didn't actually write the code. We read everything on there. And we understand what this is. This is getting our query. And then this is using the query select from toys, which is what we've got up here. So we used a variable of Q. And we set that Q to this. And then we created a variable of query, which we had up here. And we set that to select all from toys where the line where name is like or description is like. So we've got that. We're going to put that into a statement and we're going to prepare that. We're using the database and the query. We're going to bind the parameters of statement and we'll use the Q. We've got MySQLi statement, and we're going to execute that statement. And then this is going to be our result. And even though I've read all of this, I still feel like I have no idea what I'm talking about. Totally Greek to me, but we got it to work. So this is definitely a room I'm going to have to do multiple times. All right. So by hitting that, so we've got our flag. So let's go ahead and copy our flag. It says flag 1. This is not flag 1. This is flag 2. Oh no, that's flag 1. Well, we don't want that flag. Oh, we need to run. Wait a second. That's flag 1. No vulnerabilities found. There we go, flag 2. Uh-oh, there's a flag 3. Oh, no. We're still going to be doing this. That's flag 3. All right. I can inject SQL to force the database into returning Evan null as one of the receivers of the animal farm, even if Evan didn't get enough good boy score to get the present. You can access it here to see what I mean. If you access the regular link for Animal Farm, you'll see that Evan isn't a receiver. Oh, great. So there's more. There are still some SQL vulnerabilities to be fixed in the code using the help of Elf Exploit and Elf Admin and the knowledge we have gained, secure the remaining vulnerabilities of flags. Oh, I feel like I'm in the middle of taking a final and I've like studied and now I'm looking at the test and I have no idea what I'm doing. All right, here we go. Let's fumble through this. Flag 3. So we're at least on toy. I at least know how to get there. So we're going to close this one out. We're going to go look at toys. Get rid of the toy search. Save and close the file. Okay. I can already see off the bat, I see an issue. So what do we want to do here? I think we want to do int val, and we're going to wrap this bad boy. And it looks like we've got down here, query the elf itself, toy creator. Looks like we're going to be doing the same thing. Query, select all of the users where ID. Let's see where we're at. Did we break everything? Okay. We didn't break it, but we at least put that in. So now we want to wrap this bad boy. int val. I'm probably gonna break it. I almost guarantee this is gonna break it. We want to do it down here too. I feel like the only thing I know is int val. I feel like that's something I can see, and I'm like, yeah, I can do that. Come on, save. Control S. No vulnerabilities found. No vulnerabilities found. Oh, look. We fixed it. All right. We fixed toys because toys not up. So now we're at the login page. So let's. Oh. I'm feeling like I'm smart.
And there it is. Who's the best hacker in the world, people?
All right. So now we're on the login page. Not menu login. Okay. This does not look very promising. What is the value of flag 3? What is value of flag? Hey, what? I didn't get flag. Did I get a flag 3? 1, 2. Oh, I did. I got flag 3. Okay. I missed it. All right. Copy. Paste. And submit. All right. Flag 4. Now what the heck are we looking at in here? Let's read what they said. I can bypass the login screen with a SQL injection in the username. If you want to try it, use any password with the with your username, or it seems the login is sending the username and password via post. So you may want to search for the parameters sent using post array instead of get. Not that I would know any coding at all. Oh, whatever. It sounds like we need to get old McRed in here. Okay, so we're looking for post. There's post. Username, post, password, query, select all users where username all right, so it's not going to be that int I feel like they want me to write this. I have no understanding of that. So let's go back up here. Maybe we can use, I thought there was something else up here. Maybe we can use a different float val. No, it's not going to be a value, but it's definitely going to be the string. So now we're going to have to look at the string. Okay, they're getting the username, they're getting the password, they're putting it in query. So, all right, we're gonna be janky here. Let's see if I can do this, people. I'm 90% sure I'm gonna break this, and 10% sure it's gonna work. So we're gonna do this. We're going to go Q. There's our Q. We're going to put that right here. And now we've got our query statement, and we did query select from toys where username. So this is going to be, all right, here's what we're about to do. We are going to copy this because we don't want to screw it up if it is wrong. So username where name or description. So we're going to say where username where username is question mark, or wait, and we don't need to do or, and password is question mark as well. I wish there was somebody in here that would be like, no, BSEC, that is not right. That is not right. And question mark is, oh, question mark. Okay. And then we are going to prepare our statement. So we're going to do STMT statement equals MySQLi underscore prepare, and then we want to prepare the database and query. Query. All right, we did that. All right, we're gonna copy this stuff. Oop. I'm totally gonna break this. And you know what? If I do, you know what we're doing? We're gonna pull up the walkthrough and we're gonna see what I screwed up. Oh, not that one. I was about to blow that up. Oh, come on. All right, so now we're going to do this one. Paste. And we got statement, and then we get users underscore rs. And that should be fine. Users underscore. So this should be, we need to change this. We're going to change this to MySQL query. We're going to do MySQLi underscore stmt underscore get underscore result. And then statement. Who thinks this is going to work? If this works, I'm going to be ecstatic. I got a feeling it's going to break everything. All right. Control S to save it. File is saved. Oh my God. Here goes nothing. No vulnerabilities found. 1, 2, 3. Login. No vulnerabilities found. Great job. I tried to log in with a valid user, but couldn't get some. There we go. I did. I broke it. Hey, but there's no vulnerabilities found. We fixed it. There's no vulnerabilities because nobody can log in. All right.
Look, I guarantee that every single person watching this video.
All right. You know what we're going to do? We're going to pull over our walkthrough from today, and we're going to find out just what it is that we screwed up. Because I 100% need help on this bad boy. And we had a great walkthrough today done by Insider PhD. So let's pull her in and let's find out. So she did a
day 16.
So we already finished all the way through.
You can see
So let's
got another get ID.
Let's
and
pull.
we can go into here and do the same kind of int val or prepared statement. Prepared statements are usually the better option, but if it's an easy fix,
Okay, so wait a second.
int val in here, again forcing it to be an integer, and we can go into there and also make this an int val just in case, and int val again. This
Oh,
is
we've
not
already we did that part already. Okay, so we did all of that part.
Dot p in this one, quotation or 1 equals -1 secure values here. So what I'm going to do is I'm going to turn this into a prepared statement.
Okay, so we're on the right track.
Start with this query. Again, I'm going to go into here and do my question mark, and same thing for password.
Okay, we did that. We got that right here.
Question mark. So we're telling it, hey, there's going to be a string in there somewhere. I'm then going to be a bit lazy and just copy the code.
We'll see, she's going to do the same thing I did.
It's lazy, for sure. And again, I'm going to go into the... paste it in. Bam. So...
Okay, let's pause and let's look what she's got. She has users... she has the same thing we've got for here. For statement, she's got SQL query statement equals You know what? I bet if I remove this, we can actually see the color. I want to remove the... Jeez Louise. Okay, doesn't matter. So, oh, there it goes. Took a while. All right, so we've got MySQL. The statement is the same. Prepared. MySQL statement bind param. So we got bind param statement. We got SSQQ. All right. MySQL statement execute. There we go. She's got users are. So MySQL query. That's where we got. So she's got users underscore rs MySQLi query database. Let's see.
It still has 2 strings, but I'm going to tell it the 2 strings are username
Oh.
and password.
Okay, so that's where we messed up. So it's got username. It's not QQ. The strings are username. See, we're learning. Username. And then this one is going to be password. All right. Hey, if you got somebody to teach it, let them teach you.
So first thing here is we create a prepared statement with the database we were using before, and the query is the same. We just removed the strings. Instead, we put in question marks. We're binding the parameters of this statement here with a string and another string. So this is the first string, and this is the second string. So
and we're telling them that it's got to be username
and the variable password. Instead of doing MySQL execute, we're going to instead do MySQLi get result. And just...
Wait a second. So MySQL statement get result. So we got that.
Stick in statement.
Okay, so we got MySQL execute statement, and then we got results.
So I'm going to press save.
All right, so it looks like the only thing I screwed up here was I needed to put user and password in here.
And fourth one.
All right, let's back this up. So that I didn't understand. That's where I messed up. We put QQ in here, and what we needed to do is we needed to actually tell it that it's the username and the password. So now if I hit check, are we good? No vulnerabilities found. No. They tried to log in, but something is probably broken. Okie dokie. We're still crushing it. So she's got post username, post password, select from users where username. Oh, okay. Well, she's got username equals. That's a little bit different than what was on there previously. Password equals. Oh, you know what? I also didn't hit save. Not saving is killing me here. All right, so I saved it. I think we're going to be good now. Oh, we're not good. Oh. This is killing me. What am I doing wrong? All right, let's check this out again. We've got username, password. We're slowly breaking this code down. We got statement equals MySQL prepare database. in query. I'm gonna like spread mine out the way hers is. I'm gonna move. In fact, I'm gonna move this over to the other screen so I can actually see. So she's got right here. We've got MySQL. That's right, and we have bind statement, username, comma, password. Perfect. Right here. So SQL statement, execute statement. Okay. Users underscore rs equals MySQL I statement get results underscore statement. What did I break? Everything's the same. Control S. File saved. I tried to log in with a valid user and couldn't. Something is wrong. What is wrong?
So I'm going to go into here, copy it, go into this, bam.
Oh, that's her. I don't. Yeah, she already had that.
Before, and the query is the same. We just removed the strings. Instead, we put in question marks. We're binding the parameters.
Okay, let's back it up and give me the explain.
And again, I'm going to go into the...
I know y'all aren't seeing this. This is off to the side.
So it still has two strings, but I'm going to tell it the two strings are username and password.
Username and password. Okay. We've got two strings, username and password, in the statement, and that's our binding statement. So we've got that.
So first thing here is we create a prepared statement.
So we create a prepared statement. Oh, crap. Or you delete it. Control Z. Back it up. All right, we could create a prepared statement
with the database we were using before.
Database
and the query is the same. We just removed the strings. Instead, we put in question marks. We're binding the parameters of this statement here with a string and another string.
Okay.
So this is the first string and this is the second string.
Okay, I get that. So that's the first string, the second string. I'm with you.
So we give it the variable username and the variable password. Instead of doing MySQL execute, we're going to instead do MySQL I get result. And just stick in statement.
Just again, so we got users underscore rs MySQLi statement underscore get underscore result statement. Okay.
So I'm going to press save.
And she saves it.
Run the check.
She literally has the same thing we do.
First one, second one, third one, and fourth one. So I'm going to go into here, copy it.
All right. We're going to save this. Whoops. We're going to save this here. We're going to hit. We got code 1, 2. Oh my God.
Damn it, Carl!
Oh, okay. Now I'm lost because I have exactly what she does. I've got exactly the same thing she has in hers. Oh, you know what? You know what? I don't have exactly. Let me pull this over. All right, I'm going to show y'all. I just saw where we screwed up. Not we. We're me. I screwed up. All right, at the top, we've got username. We've got password. What do I have going on? Something just happened. I had an activity feed pop up. discount faker. Fokker. All right. Here's where we screwed up. And by we, I mean me. Username. Got it. Check. Password. Check. But look, we've got an extra line of code. I put the Q in there for the query. That query's already there. We don't need to do that. So I'm just going to comment that out. We're going to hit save. And I bet we're going to hit the check. And it's going to run. It's going to work. It's going to work. Scroll all the way down. No! Oh, this is me right now.
You're so dumb. You are really dumb. For real.
All right, delete. We're going to delete that out. We are going to... What do we have now? So we got post, username. We pulled that out. We're going to delete this. We're going to make ours look exactly, 100% exactly like hers. And we're going to see what happens. Because at this point, I feel like we have everything there. See, they totally hired the wrong elf on this one. I can fix their network all day long, but you give me a database? Post, password, query select from users where username and password, got that. Our next statement is going to be statement MySQL prepare database query. Then we got statement bind parameter. And that's our statement, and we're using 2 strings, and those strings are going to be username and password. Username and password, we got that. MySQL statement execute. So right here, execute. We got user result statement there. Okay, let's delete this out. That shouldn't make any effect or any change, because honestly, those are all commented out. I think the elves are just screwing with us. I think he's lying. No vulnerabilities found. Is there a way to, I guess we could preview. File located outside of workspace. Okay. I'm really at a loss. This is the first one y'all stumped me on, TryHackme. Y'all stumped me. I'm gonna turn the music up so it's not so quiet, because I've got to read through this. What do we have in here? Username. Username, password. Prepare database query. Oh, yeah. See, this is why I hate coding. I swear to God, it's going to be this. It's 100% going to be that we didn't have a damn semicomma on there. broke the whole app. See? When you're not a coder, that's what happens. All right. Here we go. Try it one more time. Flag 1, flag 2, flag 3, flag 4. Oh, golly. Copy this bad boy. And let's paste it in here for the win. Oh. And we can hit complete. This is definitely a room that I've got to go back through and do again. Because look, I don't code. I don't work with databases. But this is definitely something that I need to learn and understand. And I 100% don't, as we can tell. By doing this, it shows me that there's still stuff that's out there that I need to understand and learn. Which is great. We all should constantly be learning every single day. Learning this, it's good to know, it's good to understand, whether you're going to be doing it daily or whether you're never going to do it. It's still good to know on the back end as a blue teamer or as a red teamer to understand how this works and how you can secure it or abuse it. All right, so that's going to be it for what is today. Today's day 16. Woo, 16. Day 16 of the advent of cyber. We will see everybody tomorrow for day 17. And I believe, if I remember correctly, we're going to see the same type. We're going to see secure coding for one more day. If I'm right, we'll see secure coding. Probably going to be something along the lines of this, and you're probably going to see me fumble through it just like I did on here. But hey, that's what it's for. It's fun. It's learning, teaching everybody and learning at the same time. That's what it's all about. So for day 16, I am out, and I will see you guys tomorrow for day 17. Thank you all for watching.